So, let's start. Number 10. The mystery of time itself. Time feels simple, it moves forward, things age, and you can't unburn toast. But to physics, time is one of the biggest headaches in existence. In Einstein's theory of relativity, time isn't this steady ticking thing we think it is. It bends, it stretches, and it slows down depending on how fast you move or how close you are to a massive object. Astronauts on the International Space Station actually age a few milliseconds slower than us. Time literally moves differently. But that's not even the weird part. Some equations in quantum mechanics, the rules that describe the tiniest particles, don't include time at all, and the math still works perfectly fine without it. So maybe time isn't a fundamental part of the universe, but something that emerges from deeper physical laws we don't yet understand. Then there's the problem of direction. The laws of physics don't care which way time flows, they work the same backward or forward. But we don't experience life in reverse, coffee doesn't jump back into the cup, and dead plants don't unwilt. Physicists think this arrow of time comes from entropy, the idea that disorder always increases, but even that explanation feels like a patch on a much bigger mystery. If time isn't fundamental, then everything that ever was or will be might already exist, frozen together in one gigantic block of reality. We're just sliding through it like a needle through a record, experiencing one track at a time. And the universe? It might not be changing at all. We're the ones moving through its unchanging frame, fooled into thinking there's a beginning, middle, and end. Number 9. The cosmic fine-tuning problem. The universe looks random, but it's actually ridiculously precise, almost suspiciously so. Every single constant in nature, from the strength of gravity to the charge of the electron, has a value so specific that if it were off by even a fraction, everything we know would fall apart. Stars wouldn't form, atoms wouldn't hold together, and life wouldn't even exist. The odds of everything being this perfect by chance are so astronomically small that physicists started calling it the fine-tuning problem. Gravity, for instance, is 10 to the negative 39th power times weaker than the electromagnetic force. If it were slightly stronger, the universe would have collapsed into black holes right after the Big Bang. If it were weaker, matter would have never clumped into stars. The cosmological constant, the energy of empty space, is fine-tuned to 120 decimal places. That's not a coincidence. That's like throwing darts blindfolded across the galaxy and hitting the bullseye every time. So how did we end up in a universe that's so perfectly balanced for life? Some scientists say it's luck. Others propose the multiverse theory that infinite universes exist, each with different laws of physics, and we just happen to live in the one that works. It's like winning the cosmic lottery because all the losing tickets burned up before anyone could complain. There's also the unsettling possibility that the universe was fine-tuned on purpose, not necessarily by a god, but by advanced beings, simulations, or physical laws that somehow selected for stability. Whatever the truth is, the fact remains. Everything about our reality is balanced on the edge of impossible precision. It's enough to make you wonder whether the universe was built or programmed. Number 8. The black hole information paradox. Black holes are terrifying enough. Massive objects that crush everything, even light, into a single point of infinite density. But the real nightmare starts when you ask, what happens to information that falls in? According to quantum mechanics, information about the fundamental details of particles can never be destroyed. It might change form, but it always exists somewhere. But general relativity says anything that crosses a black hole's event horizon is lost forever. Those two ideas can't both be right. In the 1970s, Stephen Hawking discovered that black holes actually leak energy in the form of Hawking radiation and slowly evaporate over time. If they eventually disappear, then all the information about what fell inside would vanish too, violating the basic rules of physics. This is known as the black hole information paradox, and it's still unsolved. Some theories suggest that information gets scrambled and somehow escapes with the radiation. Others say it's stored in a holographic layer on the event horizon. like cosmic data written on the black hole's surface, and then there's the truly weird possibility that everything we see might already be a hologram projected from a two-dimensional cosmic boundary. If that's true, then black holes aren't destroying information at all. They're just moving it around in ways we don't yet understand. So yeah, the universe might be less like a machine and more like a very patient hacker, hiding its data until we finally learn how to read the code. Number 7, the matter-antimatter mystery. When the Big Bang happened, physics says it should have produced equal amounts of matter and antimatter, mirror versions of each other that annihilate when they meet. But look around. The universe is made almost entirely of matter. Antimatter is basically extinct. Somewhere, something broke the perfect balance. So what happened? No one knows for sure. A tiny asymmetry tilted the universe toward matter, letting stars, planets, and eventually us exist. But the cause of that imbalance, called baryon asymmetry, remains one of the biggest unsolved questions in cosmology. Physicists have tried every angle. Some say neutrinos, those ghostly particles that pass through you by the trillions every second, might hold the answer. Maybe they behaved differently in the early universe, tipping the scales. Others blame a mysterious CP violation, a subtle difference in how matter and antimatter decay. Whatever the cause, it was a 1 in a billion event. Out of every billion particle-antiparticle pairs, one lonely matter particle survived. Everything you see, galaxies, oceans, cats, comes from those few survivors. In other words, the entire universe exists because of a microscopic bias written into reality itself. The universe literally played favorites, and somehow we won. Number 6, quantum entanglement, the universe's instant messaging system. Einstein called it spooky action at a distance, and he wasn't joking. Quantum entanglement is when two particles become linked in such a way that the state of one instantly affects the other, no matter how far apart they are. You could separate them by light years and still change one and the other reacts instantly. This shouldn't be possible. Nothing, not even information, should travel faster than light. But entanglement doesn't seem to care. Experiments have proven it again and again. Reality seems to have some kind of invisible shortcut that keeps particles connected. The question is, how? Is there a hidden layer of physics we don't understand yet? Or are the two particles not really separate in the first place? Maybe they're just two ends of the same thing, like fingers on the same cosmic hand. Some scientists even think entanglement could be the foundation of space-time itself, that the geometry of the universe is built out of webs of quantum connections. Others go further, suggesting that entanglement might one day explain teleportation, wormholes, or even consciousness. Whatever the truth is, entanglement breaks every rule we thought reality had. And the fact that it works so reliably might mean we're only seeing the surface of a universe that's more interconnected than we can imagine. Number 5, the multiverse hypothesis. If you ever feel small, just remember, our entire universe might be one bubble among infinite others. The multiverse theory suggests that the Big Bang wasn't a single event, but part of a never-ending cosmic foam, with universes constantly popping into existence. Each one could have different physical laws, constants, or even dimensions. Maybe there's a universe where gravity is stronger, stars are blue, and you were never born. Maybe another where everything's made of plasma, or time runs backward. It sounds insane, but it's a serious scientific idea. Inflation theory, the rapid expansion that followed the Big Bang, predicts that if space-time can expand once, it can do it again forever, in countless regions. Some might even overlap with ours, creating subtle distortions in the cosmic microwave background, the universe's afterglow. So far, no proof, but the math doesn't rule it out. Some physicists even say the multiverse could explain why our universe seems fine-tuned for life. We just exist in the one where life can exist. If that's true, we'll never meet our cosmic neighbors, but we might share the same origin story, born from the same quantum storm, separated by an infinite sea of nothing. Number 4, vacuum decay, the hidden doom scenario. Imagine waking up tomorrow and the entire universe has vanished. No explosions, no warning, not even a sound, just gone. That's what physicists call vacuum decay, and yes, it's a real possibility. See, our universe might not be in a truly stable state. It could be sitting in what's called a false vacuum, basically a cosmic temporary setup that only looks permanent. Think of it like a ball resting in a shallow valley, but there's a deeper valley nearby. One day, a quantum fluctuation could nudge that ball, and the entire universe would suddenly fall into a lower energy state. If that ever happens, a bubble of true vacuum would appear and expand at the speed of light, erasing everything it touches. Atoms, stars, galaxies, you, me, all of it, rewriting the laws of physics as it spreads. No one would see it coming. There's no surviving it. One moment you're watching Netflix, the next, poof, reality itself has been reformatted. The scary part is that mathematically it could already be happening somewhere out there. If the Higgs field, the thing that gives particles mass, isn't perfectly stable, that means we're living on borrowed time. Some scientists think cosmic inflation or quantum effects have kept us safe so far. Others just shrug and say, well, it hasn't happened yet. Vacuum decay isn't even the dramatic end of the universe scenario most people imagine. It's worse, it's quiet, instantaneous, and completely unpredictable. It's the universe's version of pulling the plug. So the next time you worry about asteroids or climate change, just remember, the cosmos might be sitting on a self-destruct button. We just don't know when it'll get pressed. Number 3, the origin of mass. Mass feels like one of those basic things we shouldn't have to explain. Stuff weighs something. Easy, right? Not really. For a long time, physicists didn't actually know why matter has mass. Why does a proton weigh more than an electron? Why does anything weigh anything at all? Then came the Higgs boson, the so-called God particle, discovered in 2012. It confirmed that particles interact with an invisible field spread throughout the universe, and that interaction gives them mass. The stronger the interaction, the heavier the particle. Sounds neat and tidy, except it raises even more questions. For one, the Higgs field doesn't explain why particles have exactly the masses they do. Why is the top quark as heavy as a gold atom, while neutrinos are almost weightless? Why does the Higgs itself exist at the energy level it does? It's as if the universe set a bunch of dials to random values that just happen to work. And even more confusing, most of your mass doesn't come from the Higgs field at all. Around 99% of it comes from the energy of the strong nuclear force binding protons and neutrons together. In other words, most of what makes you you is pure energy, trapped by invisible glue. So when physicists ask what is mass, the real answer is still we're not entirely sure. The Higgs discovery solved one piece of the puzzle, but it left the bigger question wide open. It's a reminder that even the things we take for granted as the weight of our own bodies come from forces we barely understand. Number 2, quantum consciousness. The mind as a physical mystery. Here's a thought that makes scientists nervous. What if consciousness itself is a part of physics we don't yet understand? For centuries, physicists and neuroscientists have treated the mind as a byproduct of brain activity, something that happens when enough neurons fire. But quantum mechanics might be hinting that it's not that simple. Some researchers, like Roger Penrose, have suggested that quantum processes inside neurons could play a role in consciousness, that our thoughts, awareness, and decision-making might come from subatomic behavior that doesn't follow classical rules. It's called quantum consciousness, and while it's controversial, it raises an interesting point. Maybe the brain isn't just a biological machine. Maybe it's also a quantum computer. If that's true, it could explain things like intuition, creativity, or even the weird connection between the observer and reality in quantum experiments. Remember how particles seem to decide their state only when measured? Some physicists have wondered if consciousness itself could be part of that equation, if the act of being aware actually influences the universe on a fundamental level. Of course, most scientists roll their eyes at this idea, but they also can't explain why we experience anything at all. Why do electrical impulses in the brain create the feeling of pain, love, or fear? Why is there a you behind your eyes? The physics of consciousness remains one of the most awkward gaps in our understanding of reality. Maybe the universe isn't just aware of itself through us, maybe it needs us to be aware for it to exist at all. Number 1, the end of physics when we hit the wall. For all our discoveries, physics might be nearing its limits. Every time we build a bigger telescope or particle collider, we see more. But we also realize how much we still don't understand. We've unified electricity and magnetism, discovered relativity, and mapped out quantum mechanics. Yet the deeper we go, the more questions we find that can't be tested or proven with today's tools. Some physicists fear we're reaching a point where experiments can't go further. The Planck scale, where space and time themselves break down, is so tiny that even our most powerful machines can't reach it. We might never directly observe what happens at those levels, the math could tell us the truth, but the data might stay forever out of reach, and that's the nightmare scenario for science. What if reality has a do not enter sign? What if there are truths built into the fabric of existence that no being can ever uncover? Others are more optimistic. They say physics will just reinvent itself again, the way Newton's laws evolved into Einstein's and Einstein's into quantum theory, but even they admit we're scraping the limits of what's measurable. If the universe is an endless riddle, maybe the joke is that we're not meant to solve it. We're the universe's experiment, its way of asking itself, what am I? And maybe, one day, physics won't find the final answer. It'll just find that the question never ends. Thank you for watching and sticking till the end. We've got plenty more videos coming in the future. Hit that subscribe button so you don't miss them. See you in the next one.